Hello, everybody. Today, my name is Andy Rivenes. I'm a product manager with Database and Memory, and we have the pleasure of having Maria Colgan with us as well, moderating. For Database and Memory, it's something we call the base level feature. This is new it's new and available in the 20.3 pre-release version. And the plan, and which I'll talk a little bit about, is to backport it to 19C, but the exciting part is that we're going to allow you to use database and memory up to 16 gigabytes and not have to license the database and memory option. And so I think that's pretty neat, and I wanted to talk about that. I will probably put a blog post out. I've hesitated doing blogs in our current environment, but I will probably put a blog post out today or tomorrow that I've already written about it. But I think this is a really exciting new development with database and memory. So I thought it would be fun to essentially announce it or talk about it here. It is available in the documentation, so it's actually official and it's out. But we'll go through a few of the details associated with it. And then any other database and memory questions you might have, feel free to ask those as well. So our safe harbor statement. But we're calling this the base level feature as part of database and memory. And what this basically translates to or means for the use of database and memory is that you can now use up to 16 gigabytes. You can allocate the in-memory underscore size parameter up to 16 gigabytes and use the column store without having to license database and memory. Now, to do this, you have to set another parameter as well. We'll go through the details. But basically, all future versions. And then our plan is to, like I said, backport this to a 19C in a release update. So it won't go back to 12.102 or 12.2. But our plan is to also make this available in 19C, since that is a long-term support release. And so I think this is really neat. The motivation for doing this is that customers can see the value of database and memory. This isn't meant to make database and memory free per se, but it's really to kind of allow customers to see how fast database and memory really is. We've been talking about it for 5 years and talking about 10x performance improvements or better. And this is an opportunity for customers now to take a look at that without having to worry about licensing the option to do that. So I'm excited about it. So hopefully you guys will be as well. How this works. So I have my normal picture that I usually use showing how we allocate the column store within the SGA. And so my big, usually I tell people that typically the allocation of the column store will be in usually gigabytes, or even terabytes. We have some customers with terabyte column stores. So it formerly would have been a big picture. Here with the base level feature, you're limited to 16 gigabytes. And what happens is if you set the parameter in-memory underscore force to base level, then you're limited to 16 gigabytes or less of in-memory size. And you can allocate that here. And we'll track that as in-memory base level, and so you don't have to worry about having not licensed database and memory as an option. And again, I'll just repeat that database and memory itself is an option to Enterprise Edition. It's also available on the cloud in the Extreme Performance Edition and on the Exadata versions. And then on premises, you license it as part of Enterprise Edition. So with this new base level feature, if you set the in-memory underscore force parameter to base level, then you can allocate up to 16 gigabytes of column store, and database and memory, for the most part, and I'll give you, there's a few caveats, but for the most part will work without having to license database and memory. Now, it only works on Enterprise Edition, just as database and memory does. So you can't go to Standard Edition and use this. But other than that, it's database and memory, and so you can try it out. And I'm pretty excited. One of the questions a lot of people ask is, do I have to pay for database and memory? And it is an option, so you do have to license it. But in this case, you don't. So I think it's pretty neat. So some of the details. So in-memory underscore force has to be set to base level. And then that bypasses all of the other parts of database and memory and the option. It is at the CDB level. I actually did all this with CDB multi-tenant because that's where we're at now with the new releases. There's no non-CDB support. Now, there is a 19C, so that becomes a different issue. But in moving forward with Oracle Database, you only have CDB and PDBs. And so at the CDB level, you set in-memory underscore force to base level. By default, it's, I think, none. And so that then triggers the ability to use the base level feature. Once you've done that, then you can allocate the in-memory underscore size parameter. And what else do I have here? PDB at the level, the PDB is ignored because it's really a CDB issue, because database and memory, we allocate the column store in the CDB because the CDB owns memory and processes, and then each of the PDBs runs with those settings. The base level can't be set dynamically, so you actually have to bring, similarly to what you do with in-memory underscore size when you initially enable database memory, so you have to bring the instance down and restart it. It is possible to dynamically turn it off, but it's not possible to set it initially without restarting the database. Not that big a deal. In the CDB environment, then, each PDB can only draw the total for the CDB of 16 gigabytes. However, on rack, each instance in a rack node, so each instance of the CDB can have 16 gigabytes of column store enabled there as well. So technically, you can have more than 16 gigabytes of column store available in a rack cluster. And then each PDB can only use up to the total of 16 gigabytes. And we've talked about that in the past, where individual PDBs share that total allocation at the CDB level. So if one PDB had 16 gigabytes allocated, then no other PDBs could allocate any column store. And that's, again, set with in-memory underscore size, so you can limit how much column store is allocated per PDB.
So
I think I got everything there?
Yeah, no, that's, to me, this is fantastic news, right? Lots of people will have an opportunity to play with it. We did get a question in the Q&A hoping for 32 gig instead of 16 gig. And I think you've kind of answered that with the option on rack, because potentially, depending on the size of your rack cluster, I mean, even if you only had 2 rack nodes, now you've got 32 gig, which is what they were asking for, 16 gig on each node.
Correct. Yeah, so that's kind of cool, because racks are scale out environment, and so we're going to allow you to essentially scale out, I guess, the column store. 16 gigabytes isn't a lot, but remember, we've talked about compression in the past. Don't forget that, actually it's a good point. We limit compression to mem-compress for query low, but still, that's typically I usually tell people a 2x compression level for most objects. Sometimes you get a little more, but so 16 gigabytes is kind of 32 gigabytes of data. And then on rack, if you decide to cluster and scale that out for each instance, it's not a non-trivial amount of memory to experiment with. It won't allow you typically to run a full production workload, but that isn't the intent. The intent is to show, hey, this is really fast. We should really license this and take advantage of it. Anything else? You get anything you wanted to? This is going to be kind of I'm not really having any demos today. We're just kind of going to chat about this and then answer any questions. So it'll probably be pretty short, but I really thought, I think this is exciting. So I really thought it was worth spending the time to kind of go over the details, because we're not really having announcements of any kind right now. And we kind of snuck this in on you guys. So I thought we'd talk about it.
No, and you made an excellent point there that also came up in the Q&A, is the compression. Is that it's 16 gigabytes of memory, but it's not necessarily limited to 16 gigabytes worth of data, Andy.
Right.
And I think you've got some more details on that. But if not, can you talk a little bit about, just remind folks that as data is populated, it is going to be compressed, and that what kind
Yeah,
of
let's,
compression they can expect?
so I had exclusion. It sounds so negative, but let's just talk about it here. So compression. Yeah, database in memory, the full database in memory supports multiple levels of compression. We have query high, capacity low, capacity high. We've done some previous sessions showing how much more space you can use with the higher levels of compression and really not suffer performance penalties. However, with the base level, really what we're just after is to allow people to experiment with database and memory. So we only support mem compress for query low. So as objects are populated into the IMCUs, which we've talked about, we will do compression. So typically about a 2x, maybe a little more, depending on the data, how well it compresses. Compression is very data dependent. But we support mem compress for query low. And so that'll be the only compression. If you add a different level of compression, it'll be ignored, and the objects will populate with just compress for query low, mem compress for query low. All of the alter table in memory, priority, all that stuff stays the same. So nothing changes there. The other things that we haven't enabled with base level, which we do have in the full option, automatic in memory, which we introduced in 18C. That's not available with the base level feature. Cell memory, so you can't use the database in memory formatted data in Exadata flash cache. So that's also disabled. It's only part of the database in memory, the full option. So really what we're targeting here is the DRAM, allocating the column store with in-memory underscore size in the SGA and making use of database in memory there. The feature tracking for the licensing folks is disabled. We just track at the base level feature, so you won't get in trouble with LMS or any other folks. And it's not available, so it is available in the cloud. It's available anywhere Oracle database runs, however, not in authorized cloud environments. So other folks' clouds, even though database and memory could be used, the base level feature is not available. So those are really the only caveats, and that's not, so all of the great features with query optimization, hash joins, vector group by, all the things we've talked about over the last couple of years, all of those features are available and can be used. And so I think it's a great way to see really how much benefit you might see with database and memory if you chose to, say, buy the option and put in hundreds of gigabytes or even terabytes of data. So I think a good way to test and see how it all works. Does that cover, you think, Maria? Is there anything else I should?
Yeah, so I think you hit on several of the questions that I'm answering right now in the chat are all to do with what you've got on this slide. So
Okay.
maybe it's worth asking them to you, though, just to be sure that what I typed is clear to everybody. So the first one was, can you just confirm how the feature tracking is being done to make sure that if you're using base, that you're totally fine, and we're not going to be, LMS is not going to come after you for the database and memory option. And
I don't know who those guys are, but everybody's definitely afraid of them. Oops. So yeah. So in memory underscore force set to base level, you're free and clear. So we're going to change the tracking, feature tracking. So we're going to track it as base level, and nobody can come back and say that you violated any licensing issues. So that's in the code. And that's your protection that says that you're using the free version of the base level feature of database and memory. So that's the key right there.
Okay, and if I have in-memory force set to base level, does that mean the in-memory size parameter is limited to no more than 16 gigs? In other words, if I try and set it to 32, I'll get an error.
Yes, exactly. So I probably should have specifically put that in, but yes, that's the case. So once base level is set, then in-memory underscore size can can be a maximum of 16 gigabytes. If you set it to something larger, you'll get an error message, and it won't take. So that's your protection there. But realistically, as long as this is set, we'll make sure nothing else bad happens, basically.
Super.
And so you'll be limited to 16 gigabytes at the CDB level. So per instance, and then if you have rack, again, that's true across each of the rack instances that you have.
So there you go. You're kind of leading me into the next question we got, which was, so if I have a CDB with 30 PDBs, how would that work?
So then the 30 PDBs, so the single CDB, we said, oh, this is awesome. Let's allocate base level, and we're going to put our 16 gigabytes of column store in memory underscore size. Then each of the PDBs can use that total amount. So they don't each get 16 gigabytes. They can share the 16 gigabytes that's been allocated to the CDB. And you do that with the in-memory underscore size parameter. So you don't have to set in-memory force at the PDB level. It's ignored. It's always the CDB. And so then if you want, say just 2 or 3 of those 30 PDBs or really want to experiment with in-memory, maybe one of them gets 4 gigabytes, another gets 8 gigabytes, and then 4 gigabytes, something like that. And the in-memory size parameter, if you set that, then each of those PDBs will be limited to those sizes, and you only get a total of 16 gigabytes. So we've talked in the past about, if you don't set it, then it's first come, first served up to the 16 gigabytes. So one PDB could hog all of it. So that's your way to restrict or partition, if we want to use the word, to partition the column store memory to each of the individual PDBs that you want to allocate it to.
Sounds good. All right, the next one, I think it comes from the fact that we use a similar naming convention, is all around Exadata compression. So the question was, you said query low. Doesn't that already exist on Exadata? And perhaps you might want to explain that we use that same naming convention and similar algorithms, but let's talk a little bit about the format and also the fact that if I have HCC on disk, it doesn't magically just go directly into the column store.
Yeah, okay, that's a fair point. So HCC, so we actually have, I guess, three different areas of compression within Oracle database, right? We have advanced compression and then basic table compression as well. And then we have hybrid columnar compression, which is an Exadata feature. And that changes the format to a columnar format, but it's not database and memory columnar format that can be used on disk to basically save space. And then we have compression within database and memory. There, the idea is to save or to reduce your memory footprint, but also actually to increase performance, because we're actually able to operate directly on the compressed data, which allows you to have more data in memory than you might have on disk if you didn't compress it. So mem compress for query low, there's mem compress for query high, capacity low, capacity high. Yes, those names do track with the HCC, and I used to talk about this all the time, and now I'm blanking on the exact syntax for the HCC compression, but it is different. And then there's advanced compression, and then there's actually basic table compression and some index compression. So there actually are, maybe there's more than 3 different areas of compression. But I guess there's row level compression on disk. There's columnar compression on disk for Exadata, and then there's memory level compression for database and memory. Maybe that's the three broad categories. Yes, the names, I was saying, used to be warehouse low and warehouse high. I don't remember what HCC is. So
no, you're right. HCC is the exact same. It is compress for query high, compress for query low, and compress for
is it capacity high and
capacity low. Yeah.
Yeah, so I don't talk about those very often anymore. Again, I used to, but and if you're confused, the SQL reference manual has all of that, along with way more than you probably ever want to read about other options as well. If you're confused about the different syntax, but the idea is that HCC is separate, Row store compression is separate, and then database and memory compression is separate and is part of database and memory. And you don't have to license anything else. Just in this case, with base level, you don't have to do anything. We just do it for you. You think that answers the question?
Oh yeah, no, I think you're good. And I've put the same thing in the chat for them. So if they've got any follow-ups on that or it's not clear, they can ask another question and we can try and clarify anything. So the next one is about running the base level on Exadata. So the question is, if I'm using the base level of in-memory on a database on an Exadata environment, then is the flash cache feature of Exadata disabled or enabled?
So I want to make sure I don't screw this up, because flash cache is obviously still available for smart flash cache for the row store. But it's disabled. In other words, we will not, when we smart scan an object on database memory, the full option, will, if the object isn't populated in the column store in memory, then we will reformat that data into columnar, database and memory columnar format and make it available for queries to make use of. That feature is disabled with the base level features. That's this line here, the cell memory feature on Exadata is disabled for database and memory formats when you're running base level. So that feature, which is available automatically when you enable database and memory with the full database and memory option, it's disabled as part of setting base level. So we're not giving you everything. This is, remember, the environment is to be able to take a look at the advantages of database and memory. You have to license the product to get the full features.
Sounds good. All right, I think that's fairly clear. Okay. Can I use PMEM as part of the in-memory base, or only memory? Okay, no, actually, do you know what? This isn't to do with base at all. This one is just in general. Yeah, can I use PMEM as part of a database in memory, or only the main memory from the database servers?
So that's actually an interesting question, because obviously we have PMEM with the Exadata X8M, which is on the storage servers. So that PMEM is on the storage servers. So the answer is yes, but, and there's always a but with Oracle. So we don't currently support in Oracle database. So this isn't actually technically a database in memory, although it kind of is. We don't currently support PMEM exclusively in, I think they call it application mode, but you can't actually allocate PMEM to Oracle database as like a separate pool. You can, however, use PMEM in at the OS level. In other words, if say you have a terabyte of memory on your database server, but you have 4 terabytes of PMEM, it is possible in Linux, and I'm trying to remember what they call that mode, that you can combine all of that together and have essentially a 5 terabyte logical memory footprint. Oracle database, and again, this isn't a database and memory thing, Oracle database can then run on top of that because it just runs on top of Linux. So you can essentially have 5 terabytes of memory available, which then database and memory can take advantage of, because you could set in memory underscore size and have a much larger memory footprint than you would if you only had your 1 terabyte. So in that sense, Oracle database does support PMEM, but only in the ability to use it as a Linux virtual memory. And I'm trying to remember what that one's app mode, which is the separate, and this mode is basically, I just can't remember the name off the top of my head, but we don't explicitly support in database and memory PMEM, but Oracle database can use PMEM as part of the Linux virtual memory allocation. Hopefully that's clear.
Yeah, no, sounds good. And there doesn't seem to be a follow-up question, so I think you nailed it. The next one, which is more, I guess, of a debate style question, is there any trade-off between Exadata flash cache and IM base level?
Well, let's back up for a second and say that, so database and memory allocated the in-memory underscore size parameter, allocated allocates a column store in the SGA, and that's DRAM. And so that's going to be the fastest possible access of columnar formatted data. I usually tell people 10x. I'm disappointed if we don't get 10x. It's not a guarantee, but typically we see an order of magnitude faster scan abilities with DRAM. With Exadata Flash, when you have Exadata, you've enabled database and memory. When we take advantage of Exadata Flash, it's more like a 2 or 3x performance improvement versus 10x, because Flash is not as fast as DRAM, and we're still making an I/O call to the storage subsystem, the storage servers, to access that data. So it's not going to be as fast as if it was native DRAM in the SGA. So with that, then that preface of how that works, base level is going to be DRAM. So up to the 16 gigabytes you allocate is going to be faster than accessing that data in Flash on Exadata. And we don't support that with base level. But if you were to run, the full database and memory option and on Exadata, and you'd have the kind of what we call 2 tiers of columnar formatted data, Flash and DRAM, it's faster in DRAM. But the trade-off, I guess, is the fact that DRAM is limited even on Exadata per node to a max of 1.5 terabytes, but Flash is multiple terabytes, many terabytes of potentially columnar formatted data. So now you have a columnar footprint that can be very, very large on Exadata with the full database and memory option. So I guess that's a trade-off.
Yeah, no, you're absolutely right. I always talk about it in terms of performance and capacity, right? There is limited space, as you said, at DRAM, even on Exadata, even with 1.5 terabytes, compared to the hundreds of terabytes of data that can be in the flash cache. I think that you did an awesome job of covering that one. So this one sounds like it comes from a fan of yours, Andy, somebody who may have seen you talk at RMUG in the past. And the question is, do you have a lab that we can use to test on a laptop, like what you shared last February at RMUG?
Yes, actually. It's a little convoluted. I still haven't figured out a way so the hands-on lab that I do have on VirtualBox that's completely put together is about 10 gigabytes for the OVA, the VirtualBox image, which is problematic to make available to download. In other words, Oracle being what Oracle is, it's hard for anybody to be willing to host that. However, the Developer Days VirtualBox environment is freely available, with Oracle developer license restrictions, but is available to download and on our blog. So I'm just going to do it right now. In the resources page here on the right-hand side, I have a link to the hands-on lab, actually, that we used at Open World, and I might have put the RMUG one out there too, now that I think about it. But I have the hands-on lab guide that shows everything that we do as part of the current hands-on lab. And then I also have all of the scripts available that you can download from there as well. And then on GitHub, and I don't know if I have that link, and I guess I should put it on there. On GitHub, under my name, Andy Ruvinus, I also have a export file, which is made up of like 10, because of, again, the size, which isn't really all that big, but there's like 10 pieces of the export file that you can actually download off of GitHub and populate that if you don't want to go and get the freely available SSB generator and generate your own line order and date dim and customer file. So the long-winded answer is yes, but I don't have it where you can just download one thing, but only because I don't really have anywhere to host it. Okay. Do you think that answers the question?
Yeah, no, I think that's fairly clear. So look for you over on GitHub, which I'm going to do after the call, so I can grab that. But also take a look on the blog
on the resources page. And I've hesitated but Oracle, we're pretty good about that. So I'll put that link on with it. It's actually down a little further on this page here. But so I have the scripts, the hands-on lab guide. The schema is available. Either you could generate it yourself if you want, or you can grab the one I built. And then Developer Days has got the full like 19C, easy to download, install, and then all you do is literally set in-memory underscore size to whatever you want. Make sure the SGA is big enough, depending on whether you have an 8 gigabyte laptop or maybe larger, or wherever you're running it. And which is cool about VirtualBox, is you could put it on a Linux box as well, and you can experiment to your heart's content.
So there's a follow-on question on that. Would all of these examples apply to the IM base level as well?
Yeah, because the demo that you can download, it's only about 1,500 gigabytes of column store. I think the current memory footprint, actually, it can be quite a bit less, but I think we use about 5 gigabytes, between 5 and 6 gigabytes of VirtualBox space, because we always try to cache the rogue objects in the buffer cache to show the speed being memory to memory. But if you're just experimenting with database and memory, you can dispense with that. So it easily runs within like 3 or 4 gigabytes of VirtualBox, about 1,500 gigabyte in-memory column store. So yeah, you can do all of this within the base level feature easily.
Right, that's what I was thinking. We never go beyond 16 gigs, not even close. So from that perspective, you could easily use that to demonstrate the advantage of the base, no problem.
Yeah, absolutely. Yeah, because we, even when we use the Solution Center, we just can't have 30 installations of Oracle database running, terabyte. It doesn't work. So, right. So memory is still, it's not free. It's much less expensive than it used to be, but 16 gigabytes is still not a bad playground.
No, and especially as you said, because the data is going to be compressed. So, it's quite a chunk of data and if you were smart about what you populated, perhaps only certain partitions from certain tables, you could really get your kind of working set in memory without any. Right,
and the line order, the SSB star schema benchmark is actually fun to be able to do demos with, but I would suggest that the real value here is trying with some of your data and actually seeing, maybe even running some of your queries. If you can subset your data down, whether it's a single partition or maybe just doing selecting the data, create table as select from a subset of your data, and then experiment with your real queries and your real data and see for yourself, as opposed to our hands-on lab type scripts, which are stuff we just made up that aren't real world. That's kind of the point of the 16 gigabytes, is to be able to really try it on your data as well. So either way.
Yeah. So one last question for you. Does it work with the result cache?
Sure. It just works with Oracle database. So remember, the result cache is caching the results of the query as they come back. And so that's just a front end, if you will, to the SQL statement that you're running. And so, yeah, there's no restrictions there. That's kind of one of the cool things about database and memory, is it runs with all of the existing Oracle database features, whether it's the result cache or parallel query, or we talked about rack a little bit with having each CDB having 16 gigabytes of column store available to it. Active Data Guard in 12.2 and above, you can even have not base level, but with Active Data Guard, you could actually have a column store on your standby database. So all of these features work together. So yeah, the result cache. So then you get database and memory fast for the first query, and then instantaneous if you're running the same query over and over again with the result cache. So sure.
Perfect. And that's it. That's all of the questions we had. And I'll give folks just another minute or two in case there's anything else they want to ask. But Andy, can you let us know again where we can get more information as well as on the blog?
Yes, we have the blog, and then, thank you, we have our additional resources, really the blog, and then oracle.com, where we have a bunch of white papers listed. They're on the resources page in the blog, but then a lot of customer stories. So if you want to see how other customers have used it, our YouTube channel, where we have what we're doing with well, I guess the AskTOM sessions are separate, but they're YouTube kind of as well. But you can go to our office hours sessions, and then on our YouTube channel, we have a bunch of videos that we've done about how to use database and memory, short demos, which reminds me I still need to do that series that I was talking about doing. And then documentation. So the database and memory guide is part of the documentation starting in 12.2 and above. And so certainly the 19C or the 20.3 pre-release, if you want to learn more about the parts of the base level with this parameters, you can go to the current 20.3 pre-release documentation set. It's all documented there, so it's all official. And so all of those resources are available. Plus, you can follow me on Twitter, the In-Memory Guy, SQL Maria Colgan, and a couple of the other folks, DB_InMemory, Tanker, talking about things about database and memory and other things as well. So lots of information is available.
Perfect. Okay. So that's, oh, hold on. Of course, just as I say, that's it for questions. One pops in. Okay, so this is probably a longer question than you might want for Q&A, but in a rack environment, if one of the rack nodes was to accidentally go down, then what happens to the in-memory column store data?
So the data goes away, right? Because that's the in-memory part. So in-memory computing, you have to have the memory to access that data. So with that said, on rack, if you've distributed your data across multiple rack nodes and one of those nodes goes down, that data is gone. We'll get that, then the query will access that data from the row store. If, however, you're on Exadata, there are some options, not with the base level feature, but with database and memory, the option to duplicate data or mirror it so that if one node were to go down, that data would still exist in one of the other nodes that you have. And so then your performance or your response time performance wouldn't be affected by the loss, other than capacity, the loss of that one node. And so there are multiple options there available on rack, so rack, and then there's rack on Exadata, and Exadata gives you the ability to duplicate or mirror data for that fault tolerance. Otherwise, if one node goes down, that that column store goes away. So you have, in the case of multiple other instances, the data that's still there we'll get from the column store, and then the data that's not there we'll get from the row store, just as if you say you didn't have enough column store allocated and you only had an object partially populated.
So I think that's something we need to remember too with the in-memory column store. Like the real nice advantage of it is it's not like in-memory database where if the data isn't in memory, then it's not accessible, you get an error. You never get an error. We'll just simply fall back to the row store, the row format for that data in order to be able to retrieve it.
Right, and not to get on a sales pitch again, but and you get to pick and choose your objects. So unlike a true in-memory database, you don't have to fit everything into memory. You get to have just your current active analytic data populated, and which is again 16 gigabytes. On the base level feature is you don't have to put the entire database in that. You can actually pick and choose some select objects and experiment with your real production data.
There is a follow-on question to the rack question, but it's going to, I fear, get us down a rat hole with a parallel execution and a whole bunch of other stuff. But if one instance has a table with data that I'm interested in, and another query comes in on another rack node, how do I get that data?
And then, you kind of said that parallel query. It's a shared nothing environment. We don't use cache fusion. We don't move IMCUs across the interconnect. So in order for you to access the data on other instances in a rack cluster, we have to use parallel query to access that data. We have, I don't know if we've done a specific office hours session on rack or not. And if we haven't, I guess that'll be maybe our next one will do. Now that I have we can demo that because I have some new environments I've set up with the Solution Center that are rack enabled, which is kind of
nice.
yeah. So, where was I going with that? But it's documented in our blog. We've talked about it in the blog, and also in the documentation in the in-memory guide, how that works. But yeah, basically, for data that's distributed across multiple instances in rack, queries have to take advantage of parallel query to access that data. So
yeah. So, and I think you nailed it when there is no shipping of IM CUs or IM column units across the interconnect. We access the data where it is and just ship the results back. Okay. And that's it. You're off the hook for one more office hour, Andy. That was awesome.
Great. Yeah. Thank you for joining me. Hopefully that, I think this is a really cool feature. And so hopefully people will give it a try and then we'll go from there.
All right. Well, thanks so much, folks, for joining us. We have, hang on, one more question. Okay. If you ask it quickly, I got a question. Can I ask another question? You can, but can you do it quickly so that I can let Andy know what it is? I know it's like listening to that Jeopardy, as the clock ticks down.
Yeah, we have that sound.
Okay, if other instances can get the data from different instances in memory column store, then will it be faster? And unfortunately, there isn't faster than what, but I'm assuming perhaps I can say faster than disk. So if I can use parallel execution to access data in the in-memory column store in a different rack node, is that faster than disk?
And the answer would be in most cases. I can't always say always, but yeah, in most cases, parallel query is actually pretty efficient. And so if you're running rack on a distributed, if you're running database and memory in rack distributed, it's actually very fast. It won't be exactly as fast as a serial query where all the data is accessed from the column store. However, we recall that there's other workload as part of a query. It's not just accessing the data. And so since you're parallelized, very often that data those queries can run even faster than a serial query, even on a single instance. So it depends. What I can tell you is that many customers run database and memory on rack, and you should try it in SQL Monitor active reports, do a time-based optimization, or look at the time and where it's spent. It's a very viable, very good way to use database and memory, and it's not you're not going to pay some horrendous performance penalty for using parallel query, accessing the data across multiple column stores. You're actually likely to see even better performance in many cases.
Awesome. Okay. So with that, let's wrap it up. And again, let me just thank one more time Andy Rivenes for being our presenter today, doing an awesome job of introducing the new database in memory base level, which hopefully should get everybody now using database in memory and being able to see the advantage they can get with it.
Yes, and thank you everybody for joining us today as well. So.
Yeah, absolutely. We really appreciate it. And this session has been recorded. We will make it available through the AskTOM Office Hour website, so you can always come back and listen to the session again if you need it.
Great. And thank you, Maria, for helping out.
Hey, no worries at all. Thanks, guys.